Dear students, this video lecture will deal with master-slave JK flip-flops. Before start studying them, we need prerequisite knowledge of a few concepts which we had discussed earlier in videos. First of them is synchronization. As you know that synchronization demands that all the components present in the system trigger simultaneously and just once in a clock cycle. This can happen only if a common clock pulse is being fed to all of them. Now if you consider a clock cycle, on time of this clock cycle is too long for an active component. Active component needs a very small amount of time to trigger. Therefore, it has a lot of time remaining in the on state of the clock cycle. So it may happen that the active devices trigger multiple times in just one clock cycle, and this situation is known as race around condition. So this is the violation of rule of synchronization. To avoid it, we can reduce the on period of this clock cycle like this. But this will create a problem for the slower devices which need long time to trigger, and they will not be able to complete even one triggering in the clock cycle. Therefore, this solution cannot be used for removing the race around condition. This was actually achieved in edge triggering, and that we have discussed in detail in previous videos. We know that the positive edge triggering is achieved by the RC coupling circuit applied at the enable signal of the flip-flop. This converts the rectangular clock pulse into positive and negative spikes like this. Using this, we shorten the on time of the clock pulse for this flip-flop only, and the remaining components which may be slower are fed this clock pulse. Therefore, they are not affected at all. This positive edge triggering can also be it can be shown in the block diagram in the circuit like this. This negative triangle present at the clock signal indicates positive edge triggering. This means that the uh, flip-flop will trigger at the positive edges which are indicated in the red ink. So the flip-flop will trigger on the positive edges only. Similarly, we have the truth table. So during the whole clock cycle, only positive edge enables the flip-flop, and flip-flop behaves in an ordinary JK manner. But during the low signal, low part of the clock pulse and higher part of the clock pulse, and including the negative edge of the clock pulse, flip-flop remains disabled. Now if we place a NOT gate in front of this RC coupling, we get the spikes which are reverse in order, that is positive spike at the negative edge of this clock cycle. This means that this is also indicated by a small bubble put at the clock signal. So this means that now the flip-flop will trigger only during the negative edges. Again they are indicated in the red ink. So if we study the truth table now, the flip-flop will be enabled during the negative edge and behave in a normal JK manner. In the remaining parts of the clock cycle 0, 1 and positive edge, it remains disabled. So only for the negative edges it will be enabled. By doing so, we have restricted a flip-flop from being triggering during the other parts of the clock cycle. But this does not provide perfect removal of the race around condition. So the master slave flip flop, master slave JK flip flop is the perfect solution to the problem of race around condition. So with the prerequisite knowledge of the earlier discussed concepts, we start studying the circuit of a JK flip flop. If you uh, look at this circuit carefully, we are using two JK flip flops in tandem. That means the output of first flip flop is cascaded to the second flip flop as input. The major difference between these two flip flops is that the first flip flop, called master, is positive edge triggered, and the second flip flop, called slave, is negative edge triggered, and a common pulse is feeding both of the flip flops. So now if we study uh, uh, both the components of this master slave JK flip flop one by one, what we will get, the master flip flop is positively edge triggered, and it will behave as if it is an ordinary JK flip flop. That is, if it is as it is positive edge triggered, it will trigger at the positive edge of the clock cycle, and the behavior will be, if we provide 00 as inputs, it will be producing the last, it will be retrieving the last stage as it is. And if we provide 0 at JM and 1 at KM, it will be reset. And similarly, if we provide high signal at JM, it will be set to 1. And if we provide both inputs as high, then it will toggle. This is the general behavior of a JK flip-flop. But all this will happen at the positive edge of the clock cycle. Now let's focus on to the second part of the component, that is slave. It is called slave because it will follow the output of master flip-flop. But as as you can see that if we provide 0, if the master contains 0 at QM terminal, the flip-flop uh, the QM complement will have 1 at this terminal, because QM complement is always opposite of QM. So this input will be provided to the slave. In this case, as the input at K is high, so it will reset as an ordinary JK flip-flop does, and this will reset to 0. And if we have the opposite second case, in which QM was containing 1, so in this case QM complement will be having 0, and this pair of inputs will be fed to the slave. And because high signal at the J terminal causes the flip-flop to set to 1, so you can see in both the cases the output of this slave JK flip-flop is exactly the same as that of the master flip-flop. So this slave just echoes the output of master. Therefore, that's the reason behind the name of this slave flip-flop. But all this will happen at the negative edge only, because this slave flip-flop is negative edge triggered. So this negative edge triggered flip-flop will just delay the same output for the for up to the this will delay the same output up to the negative edge. So if we consider the pair of master and slave flip-flop as a whole, the output input will start at the negative edge of the clock cycle. Sorry, positive edge of the clock cycle, because this is the positive edge triggered master flip-flop, and intermediary output will be produced at that edge. But the slave will hold the output until the negative edge of the same clock cycle. So as a whole, the input will be started at the positive edge, and the final output will be provided at the negative edge. So it can be said that the flip-flop master slave JK flip-flop consumes full clock cycle to produce the output, because positive and negative both edges are being utilized. So there is no question of multiple triggering in the same clock cycle, as full clock cycle is required for the complete output. So we get a perfect solution to the race around condition using this master slave flip flop. Now the master slave flip flop can be the truth table of this master slave flip flop can be studied in this way. It's nothing different from an ordinary JK flip flop, but the output is produced in one complete cycle. So if we are to use this master slave flip flop in the circuits, we can use this block diagram. This MS indicates that it is a pair of master and slave flip flops. Rest of the terminals are similar to an ordinary JK flip flop. Clock signal is being provided here, J and K, and then the Q and Q complement. Uh, that's enough for the day. Thank you very much.